All right. Good morning. You are welcome to our today's class. We look at chemistry. Chemistry. So we continue from where we stopped in our last class. So where did we stop? All right. So where did we stop in our last class? What? Okay, the difference between them, right? Okay, so we'll continue from there. Hope you read the notes. So if I ask question from there, you can answer it. Eh? Okay. Don't worry. I'll ask question. I'll ask question. Have we done weak electrolyte and strong electrolytes?
Yes.
Okay. And the electrolyte and non-electrolytes?
No.
Have we done electrolyte and non-electrolytes? Okay. Okay, so now let's go to the next thing. But before I go, what is the difference between electrolytes and non-electrolytes? Tell me.
Electrolytes.
We can do what?
We can.
No, I thought you said you. I don't my part.
We can dissociate.
What? Which one?
Electrolyte. In water. With water.
Okay.
And
Which one?
okay, they can dissociate completely.
I don't my own by teaching you. I thought it is God, put it down. It's not left for you to do what? Put it here. And nobody will do it for you. Sure, you know. That is, it calls for serious studies. It calls for serious. If you don't understand, my own is to make you understand. I can't put it in your head. Hope you know. So if you don't understand it, you let me know. I will explain it. But if you understand it, then study and do what? Let it enter here. And it's you that must do it. Nobody will do it for you. Am I complete? So it's not a good start that after our class, I'm asking you on what we did. You cannot answer it. Buckle up and do something about that. Or did you not understand it? So commit it to your what? Memory. Because you cannot remember in that topic over and over again. There's no time. So commit it in your memory. It's only if there's some what you don't understand there, I will explain to you. But you see that we sit down and make sure that this is in your what? Memory. I'm employed that understanding you got from me when I was teaching it. Then look for a way to do what? Memorize it. Don't cram. Memorize it. It will be in your what? Memory. Are we together? Please study. It's very important. Study, please. Alright, now let's go to the next topic. Principles and mechanism of electrolysis. We look at principles and mechanisms of electrolysis. Principles and mechanisms of electrolysis. But before then, there's something I want to point out. Are we together? There's something I want to point out before we move. There's something I want to point out. Even though I have explained it before, but I think it's better I outline it. Key component of electrolysis. See how you can attach it, because if you don't get this key component, you'll not be able to understand the principles and mechanism of electrolysis. Put them down somewhere. Key component. I've mentioned them. I think we have done that before, but I want to bring them together so that you will be able to understand what we principles and mechanism of electrolysis. So key components of electrolysis. Number one is anode. Anode. What did I say about anode? Can you remember? No problem. Anode. You can put down something. Anode is the positive electrode. This is the positive electrode. Remember what we said about electrode? It's a charged rod, right? This is the anode is the positive electrode. Is the positive electrode where oxidation occurs. Or if you like oxidation, put in bracket loss of electron. Where oxidation, put in bracket loss of electron occurs. So the anode is the positive electrode where oxidation, in bracket, put loss of electron occurs. The negative ions. Continue. Full stop. The negative ions migrate. The negative ions migrate to the anode. To the anode. Am I communicating? During electrolysis. Hence, they are called. Hence, these ions are called anode ions. In brackets, write anions. In brackets, write anions. The second component, cathode. The second component, cathode. Cathode. It's very here. CATHODE. Cathode. This is the positive electrode. Sorry, negative electrode. Negative, not positive. This is the negative electrode where reduction, in brackets, gain of electron, close the brackets, takes place. Full stop. The positive ions migrate to the cathode. during electrolysis. Hence, they are sorry. Hence their name. Hence their name. Hence their name. Hence their name. Hence their. Hence their name. Cathode ion in brackets. Cations. System of cathode here. Cathode ion in brackets. Cations. The third one, electrolytes. Electrolytes. So the third one, electrolytes. The third one, electrolytes. Are you there? The third one, electrolytes. This is a substance. This is a substance that conducts electricity when dissolved in a solvent. Substance that conducts electricity when dissolved in a solvent. Number 4, the fourth one, when dissolved in a solvent. The fourth one, electrolytic cell. This is a container. This is a container that holds the electrolytes and the electrodes. And the electrodes. Full stop. Electrolysis takes place in the electrolytic cell. Electrolysis takes place in the electrolytic cell. Electrolysis takes place in the electrolytic cell. Is that clear now? Good. So, all these things, as I said before in our last class, anode, look up. Anode is a positive electrode. Electrode conduct electricity. I drew this cell for you that time and did not draw it. You're looking at me, I have to draw in a claim, you don't draw it. I drew something like this. This marker is not markering. I drew something like this. See, I drew something like this for you, if you can remember. This one is connected to electric power source. This thing here is electrolyte. This is the container. This whole setup is electrolytic cell because it's a container that contains both. This one here are the what? Electrodes. This one here is the what? Electrolyte. This is the positive electrode. Negative what? Electrode. So this positive one is what? Anode. This negative one is what? Cathode. So Inside here is a electrolyte. If electric current is passed through here now, remember what I told you about. Let's assume what is inside here is sodium chloride. Remember, before it is sodium chloride was solid, but when you dissolve it in water, remember that water is polar, right? It has two ends, right? Partially positive or partially what? Negative. It will impact this inside this. So as an electrolyte, this sodium chloride will not exist like this. Can you see the board together? This is how the sodium chloride will appear inside this board, electrolytic cell. When you now apply, the first thing that before it becomes an electrolyte, you dissolve it in water, which is a polar solvent. Water has two. Did I explain this? Has two dipole, two partially positive and partially negative, and so it is dipole. This will impact this charge in this thing, and it will now exist as this inside as an electrolyte. Now this is aqueous. This one is solid sodium chloride. This one is aqueous what? Sodium chloride. As an aqueous sodium chloride solution, as an electrolyte. This is one of the electrolytes, not this one. So when you now pass electric current from here inside this now, this one, they will now go to dissociate and go their separate ways. That is that dissociation we are talking about. First, from solid acceleration is like this. If you pass that electric current, they will now separate. That's what we call dissociation. So this solution is a very strong electrolyte because it dissociates completely. You now see sodium chloride on its own. Sodium chloride on its own. Sodium ion on its own, and chloride ion on its own. Is it clear? So this is what you now see. This thing now are ions. Sodium ion is a positive ion. See the positive here. Chloride ion is a negative ion. See negative here. Is it clear? Now, this positive ion, I'm using this as an example. Remember, like charges repel, unlike charges attract. As I am now, as a guy, I'm positive. You're negative, or you're negative. I'm positive. Anyone, I can easily get attracted to you. To two of us, yes, we can run things, shit. But if you see me running things with my fellow man, you look at me again. That's how you see me hold my fellow man. You see how when you came here, you see how I helped you as a woman. Then if you see me holding my fellow man like that, you be there. Oh boy, what is wrong with this person? So like charges do what? Repair. But unlike charges, I just use it to explain something. Unlike charges attract. That's why this sodium chloride will now go to negative electrode, which is cathode, because sodium chloride is positive. Is it clear? I'm not going deeply into electrolysis because there are other things. If I start studying going deep into electrolysis, sodium chloride may not be the one to discharge. Hydrogen ion will discharge, but I'm just trying to explain something. This is just a schematic explanation of what happens. But this sodium chloride will now go to where? Cathode, which is negative electrode. Is it clear? So this one now is called cathode ion or cation. Cation was derived from cathode ion. See what they did. See cathode, see ion. They removed this place and join cat and ion. They have formed what? Cation. Is it clear? So it's cation because it goes to negative electrode, which is cathode. Then chloride ion, which is a negative ion, will go to anode. That's why negative ion is called anode ion. From there you get anions. Anode plus ion. They remove this one. Join an to this ion. We have what? Anion. So that's why anions have negative charge. Cations have what? Positive charge. Is it clear? So this I just explain what I dictated for you to write. So all this thing happens inside the what? The electrolytic what? Cell. Is it clear? Happen inside the what? Electrolytic what? Cell. So if you know about, if you study your oxidation very well, you also remember that oxidation means, in terms of electron transfer, oxidation means gain of what? Oxidation means gain of what? Electron gain. If an ion accepts electron, it's called oxidation. That ion will oxidize and become a neutral atom. But if an ion loses, oxidation means oxidation means loss of electron. In terms of oxidation, in terms of electron transfer, oxidation means loss of what? Electron. While reduction means gain of what? Electron. Is it clear? Something that is positive. Look at this sodium. Sodium ion is positive ion. So this sodium ion now will do what? This positive means that electron is lower than what? Proton. Remember that in an atom, number of electron is equal to what? Number of proton. And that's why an atom is what? Neutral. But when an ion has positive charge, what it means that proton, you know that proton is positively charged, electron is negatively charged. So if it has plus, what it means is that proton is more than what? Electron. Is it clear? So because this one is lacking electron to compare with proton, it will go to where it will gain electron, so it can become a neutral atom. So if you get an electron here, and gain of electron is what? Reduction. So this one, that's why the reduction occurs at the cathode. Is it clear? Because cathode is normally negatively charged, or normally, so you can give electron to this sodium chloride, this sodium ion, to make it sodium atom. Is it clear? Now, but this chloride ion is negatively charged. This negative charge means that it has number of electron is more than number of what? Proton. So because the number of electron is more than number of proton, it will go to the electrode where it will give out this electron. And that electrode, which is anode, is positive. So electron negative will go to what? Positive. So if chloride goes here and give out this electron, loss of electron is called oxidation. So if you give us this electron here, it will become neutral, because this thing means, this minus actually means 1 minus 1. But we don't write 1, and even it's up to 2. That's why you see some ion like this. What it means that number of proton, electron is 2 times more than number of what? Is 2 extra electron. That means proton is 2 proton less than number of what? Electron. Is it clear? That's the meaning. So this one now we go to the anode. Chloride ion will go to the anode and give out this electron, lot of electron. That it will become what? Oxidized at where? At the anode. And if it oxidizes at anode, then it will change to what? Chlorine atom, which will now, you know that chlorine is normally diatomic. It will combine with another chlorine atom and form chlorine gas, which will now be evolved. Is it clear? I will see discuss this when we enter electrolysis. I'm just using this to prepare your mind, so that once we enter the mechanism of electrolysis, it will not be an issue for you to understand. So put this down, write it down, so that we can now go with this now. I think I have prepared your mind. I have prepared your mind on the what? Mechanism of what? Electrolysis, right? So we can kick off from there. I give you 30 seconds to do that, so we can continue. Okay, I'm following. Small. Like magic. It's well. Hope you had classes there.
Yes.
Okay. Okay. Are you done?
Yes.
So let's go to. Please help me print. So we now go over to principles and the mechanism of electrolysis. Continue. It has already been established. It has already been established that electrolysis is the process by which an electric current is used to drive a chemical reaction, often to split a molecule, into its constituent elements. Often to split a molecule into its constituent elements. Often to split a molecule into its constituent elements. What I put down now is what I explained when sodium chloride is splitted. Remember that. Continue. The principle. How are you? The principle and mechanism of electrolysis are as follows. So you now write subheading: principle of electrolysis. I have explained this principle, so I'm just calling notes for you. Okay? Hope you understood what I explained.
Yes.
Principle of electrolysis. Subheading. Principle of electrolysis. Okay, the principle of electrolysis. The principle of electrolysis is based. The principle of electrolysis. The principle of electrolysis is based on the fact. Is based on the fact that an electric current can cause ions in a solution to move towards electrodes. True or false? Did I explain this? It's based on the fact that electric current, an electric current can cause ions in a solution to move towards electrode, in bracket, conductors. Of opposite charge. You see it now. Sodium, which is positive charge, you move to cathode, which is what? Negative charge. Is it clear now? Opposite charge. Full stop. When an ion reaches an electrode, why did you go there? What this place is for what? Eh? When an ion reaches an electrode, when an ion reaches an electrode, comma, it can gain or lose electron. It can gain or lose electron. It can gain or lose electrons, comma, resulting in the formation of a new substance. Resulting in the formation of a new substance. Let me explain that last line. When that sodium, initially what you put, this is sodium chloride solid, for example. Now, initially this is sodium chloride what? Solid. Now, when you now add water, dissolve it, it becomes aqueous sodium chloride. It now exists like this. Remember, inside the solution. When you pass electric currents, it will split into sodium chloride and what? I know there is also hydrogen ion and hydroxide ion from water, but I don't want to discuss them. When we discuss electrolysis deeply, we can talk about that, but I just want to use this to explain something. Now, this sodium chloride now, I'm trying to explain the fact that a new substance is formed. This is sodium chloride. But if this one now, if this one goes to the cathode, goes to the what? Cathode. Sorry. If this goes to the cathode, it will get an electron and becomes, it reduce. The reduction will take place, right? It will get an electron, that is plus one electron. It reduces to what? Sodium. Solid. When this chloride goes to the anode, I follow you. It will lose electron and become chlorine atom. It will lose one electron and become chlorine atom. But chlorine atom doesn't exist as monoatomic. It exists as diatomic because the atomicity is 2. So this one will combine with another chlorine atom to form what? Chlorine gas, which will now be collected or evolved. Watch out. Sodium solid is formed here. Chlorine gas is formed here. This sodium and chlorine are not the same thing with this thing. Hope you know. Sodium is not the same thing with sodium chloride. There are two different compounds, two different substances. Chlorine gas and this are not the same. They don't have the same physical. They don't have the same chemical properties. So they are not the same thing. And because they're not the same thing, it has proven the fact that new substances are formed. Is it clear? That's what I'm trying to do. What? Explain under the mechanism of what? Action. Other things there I have already explained it before, two of us. So please, if you have a question, feel free to ask. Any question? Any question? Are you sure? Alright, so now then let's now go to mechanism of electrolysis. Mechanism of electrolysis. The main thing is to understand what happened here. Is it clear? Here we added water here. We've done this. But in fact, if you go inside that electrolyte, you also see this one inside there. But let me not confuse you with that until we go to electrolysis process. I can now add those ones. Please be fast. We don't have much time. After this, when you're done, we go to mechanism of electrolysis. Hope you drew that electrolytic cell. So as I'm explaining mechanism of electrolysis, you'll be looking at that electrolytic cell, because I will not draw it again. Are you done? Alright, so now let's look at mechanism of electrolysis. Subtitle: mechanism of what? Electrolysis. Are you there? The mechanism of electrolysis involves the following steps. The mechanism of electrolysis involves the following steps. Number one, electrode hyphen electrolyte interface. Electrolyte interface. Colon. An electrolyte is placed in contact with two electrodes. Oh yeah, go to the other diagram and let me know whether you understood what I explained about that cell. Use this cell and explain to me that last statement I made. You put down that electrolyte interface. Let me hear you, please. Audible.
An electrolyte placed in contact with two.
Okay, you tell me about what happens there.
These are the electrolytes.
Is not a.
This is the electrolyte.
Okay.
And this is the electrolyte.
Okay. So they are now in contact. Good. So that's the first step. Okay. Then the second step.
Oscillation.
Second step, number 2. Ionization. Alright. The electrolytes dissociate into ions. Which are attracted to the electrodes. Full stop. Oh yeah, look up here. Use this here and describe what I just explain to me what I just said. I'm using what I wrote on the board already. So which one is the electrolyte here? This one. Sonic solid is electrolyte. Which one is electrolyte here? This is a solid, just solid that when added with what, when dissolved in water, it forms a sodium chloride solution. So which of them is the electrolyte now? This one. Good. All right. So now, use that to explain what happened. Everything you need is here. So use it to explain what happened.
When we had it with water, it's
Water or electric current? When you pass the electric current here, what happens? Associate. To what? See it now. This is sodium. This is the electrolyte. Associate to what? Sodium ion and what? Ion. Is that clear? The next one. Number 3. Ion migration. Ion migration. Ion migration. Ion migration. Are you there? The ions migrate towards the electrode. The ions migrate towards the what? Electrodes. The ions migrate towards the what? Electrode. In fact, this here now is the ionization. This is ionization. The ions migrate towards the what? Electrode. Comma. With the positively charged ions. With the positively charged ions in bracket cations. With the positively charged ions in bracket cations. With positively charged ions in bracket cations. Are you there? With the positively charged ions in bracket cations moving towards the cathode. With positively charged ions in bracket cations moving towards the cathode. See it here. Positively charged ions will go to the cathode. And negatively charged ions, the anions. And negatively charged ions in bracket the anions moving towards the anode. The anode. Full stop. Number 4, the fourth step. Electron transfer. Electron transfer. This is ionization. See it here. Electron transfer. When an ion reaches the electrode. When an ion reaches the electrode. When an ion reaches the electrode, comma, it can gain or lose electron. When an ion reaches the electrode, comma, it can gain or lose electron. When an ion reaches the electrode, comma, it can gain or lose electron, comma, resulting in the formation of a new substance. Resulting in the formation of new substance. Look up. When sodium now get to the cathode, right? It will gain electron, right? And become sodium solid, which is different from sodium chloride. True of us, it's a new substance. This happens where? Cathode. This one goes to the anode, loses its electron, and become chlorine atom. Combine with the other one to form chlorine gas, which is different from what? Sodium chloride. And this takes place where? At the what? At what? Where does this one take place? Anode. Good. Are you doing guesswork? Are you doing guesswork? Guesswork. The answer you gave me now, is it the guesswork? Are you sure it's not the guesswork? You don't know what is guesswork?
I said I guess.
Guess something now. You know why it's anode, right? That's what I want to find out. The last stage or step, deposition. Deposition. Are you there? The new substance is deposited on the electrode surface. The new substance is deposited on the electrode surface. The new substance is deposited on the electrode surface. So this sodium now will be deposited. Look up. This sodium now will be deposited on the surface of the what? Cathode. Cathode. We didn't mention the particular ion. I am breaking it down now. That generally we know that this new substance form we deposit on the surface of the what? Electrode. So we are going down to each of these ions now. Sodium we deposit on what? Cathode. Chlorine on what? Is it clear? So this is the mechanism of what? Electrolysis.
And this chlorine change, maybe change and go to
No. It's negative charge now. Cathode is negative charge, so you cannot change. Is that clear? Now, this mechanism of electrolysis is just general. Remember, everything I've been doing here, I've been giving you general explanation. Okay. Now, next topic we are going to go now is this. Remember, there was a time I told you that in that solution, if this sodium chloride is dissolved in water, it will form sodium chloride solution. Inside that solution, there are 4 ions there. Not only sodium and no, there are 4 ions there. Remember, this is sodium chloride, right? This is sodium what? Chloride. Water has 2 ions inside it. Hydrogen ion and what? Hydroxide ion. Are you there? Water has hydrogen ion and hydroxide ion inside it. If you add them to form water. This is why water is polar on its own. When you now combine this thing that is polarly polar to this, you use it to dissolve sodium chloride. These charges will surround this ion and separate them in a bit and impact charges on this one. This will have positive charge and this will have what? Negative charge. In an electrolyte of sodium, in an aqueous solution of sodium chloride, there are 4 ions there: sodium ion, chloride ion, hydrogen ion, and hydroxide ion. So, if for these 4 ions are inside the electrolyte, and you pass electric current there, you see that there are 2 ions now that will go to where? There are 2 positive ions now that will go to the cathode. How do we know the one that should go? One must go, 2 cannot go there. One will preferentially go first before the other. So how do we now know the one that will go? Am I completing? So how is the one that is there is what is called there is what you call electropositivity. There's a scale of highly electropositive one and the one that is less electropositive. The one that is highly electropositive here is lower in electropositivity is one that will go to the cathode. While the one that is highly electropositive will remain in the what? Because it's shear man. This will get discharge, but sodium will remain in the what? Electrolytes. Am I complete? Hydrogen will go, sodium will remain. So this.
Now why will hydrogen go?
Because this is more powerful than hydrogen. So it will go. If 2 of us are, let's assume that if as we are now, maybe somebody is entering and one is ready to fight. You need to watch film now. We have the boss, those working for the boss or the actor and his people. Is it the act or the host that will go first and fight? You balance now. The small boys will go first. If they beat small boy finish, the main man will now come and two of us and tell him this one will stay, this one will go, and this one will remain in the what solution. Is it clear? So now between chloride ion and hydroxide ion, the same thing happens. So this now with this this will now take us to this little thing I explained now. Will now take us to another subtopic. Factors that will not determine which of the ions to go first. Are you following me? This will not lead us to factors that will now determine which of the ions that will go first. In a situation whereby you have four ions like this, which of them that will go first? So that's what we want to discuss now. Does it make sense to you? Does it make sense? Good. So subtopic. Factors influencing the discharge. Factors influencing the discharge of ions in bracket species. So you now understand what I mean by discharge, right? All right. The discharge of species or ions, as case may be, use as species is okay. Discharge of species. The discharge of species during electrolysis. The discharge of species during electrolysis is influenced by several factors. The discharge of species during electrolysis is influenced by several factors, which can be categorized into two main groups. Which can be categorized into two main groups. Which can be categorized into two main groups. Put colon. Number one, electrode related factors. Electrode related factors. Electrode related factors. Electrode related factors. Number two, solution related factors or electrolyte related factors. Solution related factors. That solution, it can also be called electrolyte. You can put in bracket electrolyte related factors. It's okay. Are you there? Now let's start with electrode related factors. We listed the factors, the two main factors now. So we're starting with electrode related factors. Are you following? Because you did your face as if you're confused. So electrode related factors. The first one, number one, electrode material. Electrode material. Electrode material. Electrode material. Alright. The type of electrode material used. The type of electrode material used. The type of electrode material used can influence the discharge of species. The type of electrode material used can influence the discharge of species. Of course, when I say species, you know what I mean, right? You know that. Do you know why they call it species? Because sometimes it may not be like now. Look up. This one is a ion. This thing now is this hydrogen ion is a ion. This one is a ion, but this one has two things inside. This OH is hydroxide ion, I will know, but it has two things inside. It's called a radical. Is it clear? So both radical and the one that has only one element inside it, what of them are called what? Species. Is it clear? Good. So I said, where did we stop in the notes?
The discharge of
The what?
electrode material, the type of electrode
Material used.
can affect the discharge of
Issue. For example, keep writing. For example, inert electrodes. Inert. Do you know the meaning of inert? If something is inert, do you know what it means? It does not react. Inert, it does not react. Okay? Alright. Inert electrodes. Inert electrodes, such as platinum or graphite. Platinum. See this spelling here in case. Or graphite. Inert electrodes such as platinum or graphite may not react with the electrolytes. May not react with the electrolytes. While reactive electrodes such as copper or zinc may participate in the reaction. While reactive electrodes such as copper or zinc may participate in the reaction. Welcome. Are you science or article line? Are you doing biology? So you came late today, why? Alright, so we'll stop here. But before I go, I want you to know if you have any question to ask. I'll ask you. No, we did just one of the under this electrode related factors. This is one of the electrode. There are other electrode related factors we discuss before we now enter the solution related factor. Is it clear? So, do you have any question to ask? I'll ask you. So what is? Tell me what you understand by mechanism of just general note, describe mechanism of electrolysis program. Just tell me what happens. Don't it mustn't be specific. Don't go to specific. Just tell me what happens. Just describe it. Just how it is in Yama. Just say it. Don't try to make it look wonderful.
The deposit of electron and neutron. specific particle. Contains the electricity contains the electron and the proton. No,
You have the idea.
Flow, yes.
You have the idea, but you are missing it off. You have the idea anyway. After you get you know from her, then you cannot have the proper picture. We'll stop here. Go back and study what we did. In the next class, we explain it. Even if you enter here, you explain it to us. Is it clear? Thank you very much for your attention. God bless you. See you next time.